Speaking to a student over here just before, a lot of this is vaguely reminiscent of stuff that you've done before. It should be. It was year 10, okay? But I don't like saying you should know this from a previous year. I'm always going to teach it from scratch, okay? So we need to revise the idea from year 8. You are taught how to solve linear equations with a single variable. So how would we go about solving this? 2x plus 3 equals 7. How would I get rid of the plus 3? What's the opposite of adding 3 to something? So you would be able to do that. 2x plus 3, take 3 is going to be 7, take 3 is going to be 4. That's the first step. What's the 2 doing to x? Timesing. So you divide both sides by 2. So x is going to be 2. You can solve that. However, when you have 2 variables, you would get stuck with that strategy. Can you solve x plus y is equal to 9? Can we do something? What could I do to get rid of plus y? What's the opposite of adding y to something? Subtract y. So I could do that. Yeah, there's nothing wrong with this. But I'm not any closer to solving it because I've got 2 things that I don't know. Okay? However, if you have another linear equation that relates to the same x and y, you can find x and y. When you have multiple equations referring to the same variable, they're called simultaneous equations. We can show that equations are simultaneous by grouping them with curly brackets like this. So that's the first notes that you should take is indicates x and y in both are the same, therefore simultaneous equations, because that shows that x and y in both are the same thing and that allows us to solve it. So can you please get this to start off with, and then I'll introduce a situation. It's sad, those guys are away for tourism. I tried to do semi-similar names without getting told off, because that's Luca with a K. So just grab that. How do we show that equations are simultaneous? We put curly brackets. And what I'm going to show you here is a situation where simultaneous equations would be useful. Then I'll show you how to solve them. All right, what's a situation that could involve simultaneous equations? Let's pretend Luca with a K is new to the school. He doesn't know the prices at the canteen and he's got crippling social anxiety. He doesn't want to go to the canteen. So he sees that his friend Daniela bought 1 pie and 1 sandwich. And Daniela spent $9 in total. And his other friend Soy bought 2 pies and 4 sandwiches for $24 in total. If Luca decides that x represents the price of pies, y represents the price of sandwiches, could we make an equation for Daniela's purchase? So let's highlight the information about Daniela. Daniela, 1 pie, 1 sandwich, $9.
X plus y is 9.
Yes. X plus y equals 9. By itself, I can't solve that. But what did Soy do? Soy, 2, 4, 24. So someone else. What would Soy's equation be? 2x plus 4y equals 24. Can we check in our minds, do these equations both refer to the same x and y? Is it the same canteen? Yes. Because that's the case, because it's yes, they are simultaneous equations. We can write them with the curly brackets. 2x plus 4y equals 24. Can I give you some time to get that example down? Because I haven't shown you how to solve that yet. I will show you how to solve that in the next lesson.